not. So we left off yesterday, PCl5. There was 1, 2, 3, 4, 5 things attached, which was sp3d. I'm trying to look at AP Classroom at what they have on hybridization. It's way less than what I've already taught you, I believe. So, and AP Classroom is also not working today. So, yeah, kind of unfortunate. So, next we're going to do is SF6. So SF6, sulfur. Well, I mean, there's nothing super special about this. It's basically sulfur with fluorine, 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 1, 2, 3, 4, 5, 6, and these all have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. SF6.
Whoa.
So that's the Lewis dot structure. And I hinted to this yesterday that the electron pair structure was octahedral. It was octahedral. And that's based off of how many faces there would be on the outside of that 3D shape. Or sometimes you'll see it as square pyramidal. All right? I can't spell. Pyramidal. Because if I flip over to my molecule maker, and if you guys want to grab a laptop, you can, as we're working through this. If I add a sixth one, and I flip over to HDMI, you can see that, do you see the square in the middle?
Yeah.
And then there's a pyramid on the top, and then there's a pyramid on the bottom. So either one is actually accepted.
I think that's the first one I've actually tried.
All right? So square pyramidal.
Wait,
Square.
why is it not the bipyramidal?
I don't know. That's just what it is. All right? I didn't make these names up.
I should just be able to call it whatever I want.
I did not make these names up. Oh wait, you're right. Duh, it is square bipyramidal. That's my bad. All right, it's square bipyramidal.
Okay.
That makes a lot more sense. Square bipyramidal. Let me make this a little bit larger if possible. Square bipyramidal. Good catch, Brendan. Square bipyramidal. Or octahedral. How many things do I have connected? I have 6, right? So the hybridization is going to be sp3d 2. Yeah, because the exponents have to add up to the number of sites. So 1s plus 3 p's plus 2 d's is sp3d2. That's your hybridization.
Diagram, the off-ball diagram for what that would look like?
That would be, it'd be similar to this, just one more. But I really don't want to concentrate too much on the off-ball.
Should be like one of the 3p would be promoted to.
Correct. Because there would be, this would be full. So you're actually going to promote, yes.
Okay.
You got it. My molecular structure, is there any lone pairs? No. So my molecular structure is also going to be octahedral / square by pi, right?
So a lone pair is when it's the only one.
The lone pair is if there's just 2 electrons by themselves.
Okay. And then the rest are shared.
Yes. Angle.
Yes.
What are my angles on this one? All of my angles are actually 90. All right? Can you guys see it? You see it? Yes? So my angles are all 90 degrees. And is this polar or non-polar? Non-polar. There's an even distribution of charge on this one. It's non-polar. Non-polar.
What was the one above? Was it polar or non-polar?
This one?
Yeah.
PCl5, let me think. That'd be non-polar. This was non-polar. Most of the time, if there's not lone pairs, it's probably going to be non-polar.
And you mean lone pairs by?
Lone pairs like individual lone pairs of electrons. Like a lone pair is, that's a lone pair.
Okay.
2 electrons. Okay. What about, yes?
What's the first word after the dash, that word?
This one?
Square.
Square?
octahedral slash square by pyramidal. I usually just do square by pi, or try by pi. Now, as I said yesterday, you are only responsible for knowing molecules on the AP test up to sp3 hybridization. On my test, you're responsible for knowing up to sp3d2. So my test is more difficult than the AP test. Yes?
I still don't know how to determine the hybridization.
Use
Okay,
it.
we're gonna do a couple more.
Okay.
Let's do a couple more. So let's do water, H2O. So H2O. Total of how many valence electrons?
8.
8. We know that it looks like this. I have an oxygen, I have a hydrogen here, a hydrogen here. All right? And I'm going to go over to my molecule generator. Let me get rid of some of this. So here's my water without lone pairs. How many lone pairs am I going to have to add? 2. Agreed? If I add one lone pair, what's it going to do to those? It's going to go from linear. It's going to make it, it's going to push it down, right? Yes? So now I'm going to try to do the view for, you guys. Now it looks like this. Yes? Where's the second lone pair going to go? Yeah, it's going to go like this, right? Because it wants to spread out as far as possible. All right? So my electron pair structure. My electron pair structure. This is where are the electrons at? How many total electron pairs do I have connected? 4, right? I've got 4, agreed? Because I have one lone pair, one bond. Yes? 4 is what shape? Tetrahedral. Yes. So my electron pair structure is tetrahedral. My electron pair structure is tetrahedral. Now, hybridization. My hybridization, I gotta finish drawing this, is how many bonding sites are there, Brendan? Total. We just said it. There's 1, 2, 3, 4, right?
So we're counting the lone pairs too.
Yeah. Lone pairs count. So there's 4, right? So that means I need 1 S and how many P's? 3 P's. SP3. So my hybridization is SP3. So you just look at your total number of bonding sites. You have 1 S available, you have 3 P's, and then you have 2 possible D's. You'll never have anything past SP3D2.
So you're saying so we're assuming like the exponent of S is 1.
Yep.
And that's what you're saying.
Yes, the S is an exponent of 1, but we don't show that.
Okay.
Cool? Now, my molecular structure is different. Molecular structure is only where are the molecules. So, my molecules, ignoring my lone pairs, what shape is that?
Trigonal.
It's bent.
What?
All right? How'd you know that, Eric?
My dad helped me.
Ah, yeah, it's bent. All right? So the molecular geometry is bent. There's no triangle there, really. I mean, it's just kind of bent. All right?
I definitely see the triangle.
I mean, it's bent, though. That's what that's called. It's bent.
So wait, if there's lone pairs, molecular structure is different than.
If there's lone pairs, your molecular structure is going to be different than the electron pair structure.
Can we see trigonal planar again, really quick on there?
Sure. Trigonal planar. Let me get rid of this. Here's trigonal planar,
Okay.
right?
Yeah. It's like the nucleus doesn't really count. Or not the nucleus.
The thing in the middle.
Yeah.
Yeah.
I see that.
But we're not looking at that. We're looking at water, which has 2 lone pairs,
Yeah.
which pushes them away,
Uh-huh.
and that is called bent.
Yeah. Because it doesn't really make a triangle.
That's bent. Angle. Angle is based off of your electron pair structure, which is tetrahedral. So our angle is 109.5. 109.5 is tetrahedral. 109.5 is tetrahedral. And polar or non-polar? Water is definitely polar. All right? Because I have an uneven distribution of charge. I have negative on this side, and I have positive on this side. It's an uneven distribution of charge. So, We're now going to make a chart. All right? Kind of talks through it all. Okay? Kind of summarize it. So, here we go. You're going to want a page for this. So, we're going to have electron pair sites for my first column. I'm going to have electron pair structure. I'm going to have hybridization. And I'm going to have molecular structure. Those are my 4 columns. So, if I have 2 electron pair sites, so I'm going to go back here. I'm going to delete my lone pairs. All right? If I have 2 and I go here, what is my electron pair structure? Linear. It is linear. It's a line. What is my hybridization? 2. 1 S? One P. SP. My molecular structure is also going to be linear. I'm sorry. I'm flipping back and forth here. So I have 2 sites. My EPS is linear. My hybridization is SP. My molecular structure is linear. Now, if I go to 3, if I go to 3 electron pair sites, we know what this is. We did this yesterday. That is what shape? Trigonal planar. You got it. This is trigonal planar. Trigonal planar. Hybridization is? SP2. SP2. Molecular structure is also trigonal planar. But that's not the only possible molecular structure. Right? Because I could take away a bond and instead add a lone pair. Now what shape do I have? So my second possible, you got it, is bent. Good. My second possible molecular structure for 3 sites is bent. And if we want to get really crazy, and we delete another bond, all right, and add a second lone pair, now what shape am I? Linear. My molecular structure is in a line. It's linear. Stop. All right? It's linear. It's linear. Let me flip back. So those are all my possible molecular structures, or most of them, for 3 electron pair sets. I think it's all of them. All right? It's pretty good. All right? It's pretty good. I'm going to give you a printed version of this pretty soon. 4 electron pair sites is what electron pair structure? Tetrahedral.
That's right.
Tetrahedral. Hybridization is? SP3. So now you can kind of see, we're just adding 1 every time for hybridization. So the first one is tetrahedral. Tetrahedral. So then let's go to our second shape. So let's get rid of our lone pairs. So there's my 4. If I delete a bond and I add a lone pair, what's it going to get? It's going to go from this to trigonal pyramidal, right? Because it pushes it down because the electrons want to repel. So I go tetrahedral, I can go trigonal pyramidal. You know what's coming, all right?
Yes.
Here it comes. If I delete another bond, add another lone pair, I am now bent. Yes,
Yes.
I'm bent. I am now bent. And here's the coolest one. If I delete another bond and add another lone pair, check it out. I'm linear again. All right? I'm linear again. So linear is the last possible one there. So that is linear. Let's go to 5. For 5, my EPS is what? Tri by pi. Tri by pi. Trigonal bipyramidal. Hybridization is now sp3d. sp3d because I have to add another one. Because I have 1 plus 3 plus 1. So my first one is tri by pi. All right, I want to see if you guys can get this next shape on your own. Okay? So I'm going to turn off my molecular geometry. All right? And see if you guys can get this. So here's my 1, 2, 3. We at 5?
Yeah.
There's my tri-bi-pi. I'm going to delete a bond, and I'm going to add a lone pair.
Can you give it some spin?
I can give you a spin.
Oh my.
What?
I know.
Oh. Okay.
Eric?
Here, I'm going to give you a hint.
Does that know?
Don't tell people, Eric.
Eric already spoiled that. Eric spoiled it.
Do you guys not see it?
Bench.
Seesaw.
Let's go.
Do you see the seesaw?
No.
It's a seesaw.
Yeah, I just see it first.
Do you see it? I was trying to make it go up and down.
I was thinking like blind bag.
It's a seesaw. All right?
Dude, literally. This
That's a
thing-
seesaw.
Is that the scientific term? Seesaw?
Yes, it is.
I love that.
Seesaw. The next one's easier for my molecular shape. Let's delete a bond. Let's add a lone pair. You guys can do this, right?
Oh. Trigonal plane.
No. Guys, what is that?
That's a T. It's
A T. T-shaped. That's T-shaped.
No.
That's T-shaped.
I thought trigonal.
That's T-shaped.
We're just making this up now. This can't be real.
T-shaped. And we can delete one more. You guys are getting it. Let's delete one more. What's this going to be?
Bench.
I don't know yet.
Linear.
Linear.
What?
Because they want to those lone pairs do not want to be by each other. They want to repel. So that is linear. Yeah, a lot of you have to just memorize this. All right?
That sucks.
A lot of you are just going to have to memorize this. And then let's go to 6 for octahedral.
Oh, I hate it.
Or if you want to do your square bipyramidal, I'm fine with that. Let me flip back to my page. So I am at SP3D2. So my first one is octahedral. Octahedral. So let me get to my octahedral. Here's my octahedral. All right. I'm going to delete a bond, add a lone pair. No, not the same shape.
Square by
3D.
Not square bipyramidal,
pyramid.
square pyramidal. There's a square and only one pyramid on this one, right? We're only looking at the molecules. So that is square pyramidal. That is square pyramidal. Square pyramidal. All right. Let's delete another bond. Delete another bond. Add a lone pair. What's it going to be?
Square.
Square planar. Square in one plane. That's square planar. Square planar. Square planar. And if I delete another one, we guys already know this. Delete another one. What shape do I have now? T shape. I've got T shape. I have T shape. And if I delete one more, which I can,
I swear this is bench.
delete one more, add a lone pair, I am
Linear.
linear.
Let's go.
Because those lone pairs want to repel as far away from each other as possible. Hence, repulsion theory. Linear.
Okay, can you stay on the other page for just a second?
Yes, I can. Yes, I can. So that is linear.
Is that it?
What?
Is that it for that one? This
That's
is
it
all-
for that.
Yeah, this is
How
all
far do they
three.
go to the real science?
Right?
Probably like the last
it for that?
test is the last one that we learned in
Wait, so-
Chem. This is all new.
Yeah, that's all new from here out.
Yeah.
All right? There's nothing review.
Everything you learned in
So
Chem,
it's
we've
even
done
playing field.
already.
Even playing field.
Yeah.
Even for Marin. All right? Even for Marin. So, that's the possibilities. That's the possibilities. So, I wanted to show you a couple more things, do a couple more in practice the last half hour we have today. Because I really want to finish the notes since Abby's not going to be here tomorrow. And I just want to finish them today. This works a lot better in a full double period note giving, but we don't have that. So,
Yeah, we just had a date disconnect, but now it makes sense.
yeah, it should be making more sense now. Are we feeling better today?
Yeah.
All right, it works when you work through it like this. It works a little bit better. So, It takes time. So some of you are like, I don't envision this at all. Well, you're gonna have to memorize this. Okay?
Are you ready to memorize?
Memorize this. Okay? Some of you can envision it. That's fine too. That's fine too. So I'm going to turn my page just because this is kind of other stuff, and I'm going to draw ethene, which is C double bonded to C, with an H here, an H here, an H here, and an H here. So I have carbon 1 and I have carbon 2. The name isn't important. The name isn't important. Let me zoom in just a little bit so you can see this a little bit better. So let's look at carbon number 1, because it's the same as carbon number 2, but that's fine. All right? And let's do our off-ball diagram, because I know Jacob's been dying to do some more of these off-ball diagrams. All right? So here's my 2s, and here's my 2p. Carbon has how many in the 2s? 2, which is an up-down, right? And how many in the 2p? 2. An up and an up, right? But how many things do I need to connect to this carbon? How many bonds do I need?
4.
I have 1, 2, right? 3, 4 bonds. Agreed? Yes? So what do I have to do to this one electron? I'm going to promote it. All right? I'm going to promote it. So what am I connecting at this first spot? It doesn't really matter, but let's say I'm connecting what? Let's make a hydrogen here. So here's an H going down. What am I going to connect here? Another hydrogen. What am I going to connect here? The other carbon. Oh, snap. That leaves me 1, right?
Is it a double bond?
That's the double bond. And this one that is here is called a pure p orbital. All right? That's a pure p.
Aren't 2 bonds to the other part?
What?
Aren't there 2 bonds to the other part?
Yes, but it only really takes 1 to connect it, right? It only takes 1 to connect it. This is also going to that carbon, but this is just an extra pair of electrons that's bonding it to make that double bond. What? This is not hybridized, is what I'm showing you. This is not hybridized. This is not hybridized. How many bonding sites do I have?
3.
I only have 3 bonding sites. Agreed? I have 1, 2, 3. I only have 3 bonding sites. So that means this hybridization is what? sp2. You got it. Because that is a pure P.
Oh, so that's how they treat it.
How do we
Yeah.
tell that
It's not
a
tricky.
is pure?
What?
How do we tell it's pure?
Because it's a double bond.
Any double bond is it pure?
The second one, a double bond, is a pure.
So like if you have like
And
a cyanide ion,
So that means it's
Yeah.
a pi
then
bond.
they only share.
It's a pi bond, yes. So a pure P is a pi bond. In a triple bond, there's 1 regular, and then there's going to be 2 pure P's, or 2 pi bonds. So all you have to know is the first bond is a single hybridized bond, and after that, they're not hybridized. They're just pi bonds.
So like cyanide, we would only have 1 hybridized.
You
bond
got it.
and 2 pi bonds.
Cyanide would have a sigma bond and 2 pi. A sigma bond and 2 pi. So let me draw this for you. I know you love this, okay, when I draw it, but let me try to draw it for you to show you what the pi is. We know that sigma is end to end, right? And I said that pi was like this. So I'm going to try to draw it. So here we go. Here's my carbon in the middle. So it has 1 here, like this, right? And then it has 1 kind of like this. This is not going to be my best drawing. It's fine. Guys, this drawing is not important, okay?
These are the SP hybrid.
I'm just trying to draw this for you, okay? And then, I already drew this horribly, but that's okay. I'm going to draw the other one over here. All right? Draw the other one over here, just so I can, it's fine, guys. I promise. All right? I promise. All right? So, you guys don't even have to draw this in your notes if you don't want to. I'm just trying to show you. These end to end, all right? Do you see how these are end to end?
Yeah.
That is a sigma bond, a single bond, all right? That's the first bond right here. Are you guys okay with that?
Yeah.
Do you see how these orbitals are more side to side?
Yeah.
They're like this.
They're vertical. and
They're vertical and not horizontal.
Okay.
Those are a pi bond. All right? So the first bond is a sigma, the second one is a pi. Which what I'm trying to show you is in a double bond, I have 1 sigma and 1 pi. In a triple bond, I have 1 sigma and 2 pi. I have 1 sigma and 2 pi. So that's what I'm trying to show you there. All you have to know, I'm going in more depth than I need to, okay? All you have to know, according to AP, is a single bond is a sigma bond. A double bond is a sigma and a pi, also known as a pure P. Pure P is not even in the AP, all right? I'm going farther than I have to, okay? Pure P is not even in the AP. A triple bond is a sigma pi pi, all right? So single sigma, double sigma pi, triple sigma pi pi. Got it? Sigma pi pi.
Sure.
So here we go. You guys do this on your own now. So here is HC triple bond CH.
What's that thing called?
What's this?
Yeah.
This is ethine.
No.
Ethine. Ethene is a double bond. Ethine is a triple bond.
That-
We don't do organic in chem.
This can't be good.
Did you guys even get to organic in CP Chem?
No.
Yeah. But that's ethine. All right? If I was going to draw this, first of all, what's the hybridization of carbon number 1?
What we doing?
What's my hybridization of carbon number 1?
SP.
Carbon 1 is just sp, 2 bonding sites, right? How many sigma bonds do I have here on this triple bond? I've got 1 sigma, right? This is 1 sigma, and how many pi? 2 pi. 1 sigma, 2 pi. I could draw that, but I'm not going to. Because it would look like 2 going like this, right? Those would be my 2 pi's. There'd be a sigma in the middle, and then 2 going like this on the other side. You don't have to draw it. I'm just trying to show you multiple modes if I can. Do you guys got the sigma pi? Yes.
For the most part.
Clear as mud.
Yeah.
Okay. All right, here we go. SIF4. On your own. Draw the Lewis dot structure. Give me the EPS, hybrid, molecular structure, angle, polarity. So I want the EPS. I want the hybridization. I want the molecular structure. I want the angle. And I want the polarity. Also draw it. SIF4. We're going to finish this. We got this. Nothing special about the Lewis structure, right? No lone pairs. Which means my electron pair structure is tetrahedral. 4 bonding sites. Hybridization is sp3. Molecular structure, are there any lone pairs? Tetrahedral. Angle 109.5. Polar or nonpolar? You got it. Nonpolar. Nonpolar. Another one. NO3 minus. NO3 minus. We're just going to practice a few of these. Just going to practice a few. I can't believe it was 50 this morning and then it snowed.
Yeah.
That was quite the cold front.
And then soon it should be more. again.
You guys got it? How many total electrons?
31.
24.
Yeah.
Shoot, there are 6. That explains.
6 times 3 is 18. Plus 5 is 23. Plus the negative is 24.
Yeah.
The minus 1, you got to add 1.
That's a good start. I've done one thing right.
So,
That's what I got to.
did you draw this? And O, O, O. And did you put it in a bracket because it had a negative charge? And did you show that there's resonance?
No.
You guys didn't show it.
Right? Because that double bond can go on any of them, agreed?
How do you show the dashed?
I just do a dotted line to show that there's
Could you
resonance.
not do the,
Lone pair.
The lone pair? Yeah, there's a lone pair. Sorry. There's a lone pair.
Wait,
I meant like.
that's it. Yeah, I meant on all the O's.
Oh. Well, so when you're doing the resonance for this, I guess you could like pick one to show the lone pair on. When there's resonance, I don't personally care if you draw the lone pairs. So if you want to pick one, I would just pick one.
So is there a lone pair on the end though? Or is that wrong?
No, there's no lone. Wait, there's no lone pair on the end, right?
Yeah,
No, that's not there.
Oh,
Yeah.
Nitrogen has 5 valence, right?
Nitrogen has 5. Correct.
For each of the bonds 2 share,
Yes.
then it would show.
Well, this is showing that the double bond can go on any one of the 3.
Right, but still with one bond that's 2 each, right?
I got 2, 4, 6. Let's say this is a double bond. 8, 10, 12, 14, 16, 18, 20, 22, 24.
So it doesn't matter that the nitrogen has more than. Oh, because it goes to a full outer shell.
Right. The nitrogen only has
I got it.
1 double and 2 single. It only technically has 1 double, 2 single. Right? So, EPS. How many things connected? You missed a lot.
Trigonal planar.
How many things are connected? How many bonding sites?
3.
3. So trigonal planar. Good. Trigonal planar. Hybridization is sp2. Molecular structure is trigonal planar. Nice work. Angle,
That's where I get off. I have no idea.
120.
Why is it 120?
Well, if it's a if it's a triangle on a plane, right? 360 is the plane. But if I divide it by 3, 120,
Okay. That makes more sense.
right? 120. Polar or nonpolar?
Non-polar.
Nonpolar. Nonpolar.
So it's not straight like that shows, right? It would have. It would be
No,
more
it's
kind
and you guys don't have to draw it correctly.
Nice.
All right. I don't care if you draw it correctly. Maybe it helps you to draw it correctly, but AP doesn't care. All right. AP, in fact, is going to draw it like this, and you're going to have to know what it actually looks like.
Gotcha.
All right. So I'm going to give you 2 more to try on your own. Do NH3, and then IF5. Do those 2 on your own. I have to run over to the lab for Mr. Knight. Somebody spilled all of this calcium. So this will take me 2 seconds to make.
Drink it. You will grow big and strong.
Balsinger got it.
Totally forgot about the like thing. That doesn't help, does it?
Forgot about the thing.
Where you do the charges of 5 valence.
Oh, you're talking about the formal charge?
Yeah.
I don't think formal charge is going to be here.
Is that what?
Yeah. So as you guys are working on that, here's this.
That's
Right.
so helpful.
Funny story about this. I don't know if you guys ever knew Will Gasteyer, Alazar Coetzee. You guys probably don't know them. But the first year that I taught AP Chem, I think either Will or Alazar made this. And I wasn't supposed to see it, which didn't matter. Because they were obviously like the first thing, so I was like, oh, I hate doing this. And it was named literally the BULLSHIT shape chart. So then I found it. I'm like, who made this? And they're like, that's actually pretty good. Like, can I use this for everybody? And like, I wasn't upset.
I'll make it.
So from this point on, I always call it the BS shape chart because that's what they call it. So I've kept the name for you. But it's nice because it has everything on there in better handwriting than mine.
I'll make it.
But that's everything. Kind of nice.
Very big.
It's very dramatic.
The music,
Yes.
it's something. You guys done?
Sure.
No. Almost.
What just happened? No.
I did this again,
Huh?
I took out both right.
You drew them right?
Yeah.
The drawing's not the hard part. It's just everything else.
Well, I thought that was hard because I thought I did it wrong.
Oh.
I'm surprised.
Oh, is the drawing the hard part?
Myself.
Sticking out of there.
So you just have to think for if there's lone pairs, like the lone pairs want to get as far away from other electrons as they can. And on this one, each one, it doesn't really matter where you put the lone pair. NH3, electron pair structure is electron pair structure, tetrahedral. Because you include the lone pairs. This is how many total sites? 1, 2, 3, 4. That's tetrahedral.
Yes.
Hybridization, sp3. Molecular structure, trigonal pyramidal. Good work.
Wait, so why is that?
So this one is trigonal pyramidal because before I put the lone pair, it's flat, right? It's flat in a triangle. Then I add the lone pair and it pushes it down.
Okay.
And it's only where the molecules are.
Okay.
Only where the molecules are. What else do we need to do? Angle. 109.5. The angle is based off of the molecular structure, right? The angle is not based off of your electron.
Because it changes the shape.
I'm sorry. Your angle is based off of the tetrahedral, off of the EPS. I said that backwards. I've got 4 bonding sites, 109.5. Polar or non-polar? Polar. This is polar. Down here, did you guys kind of think as you were working through this, like, oh, check this out. Here's a square, right? And then this kind of like comes up to like a pyramid, kind of. Yeah?
That hurt.
I know, fancy. EPS on this one, how many sites? 6. So this is
Try by pi.
octahedral, or you could say square by pi. That's not try by pi.
I forgot.
It's either octahedral or square by pi. Square by pi?
Square by pi.
I'm square by pi right now. All right. When I talk like that. Hybridization is sp3d2. Excellent.
Oh.
All right. I tried to give you a hint for the molecular structure. What is it?
Square.
Square pyramidal. Square pyramidal. Square pyramidal. Angle is? They're all 90. Polar or non-polar? That's polar. Got a lone pair, right? This is not an even distribution. Not an even distribution because of that lone pair. Okay. IF3 and XEF2. Yeah.
Oh, but it's noble.
Well, it's possible.
Get off your high horse, Xenon.
You can make that. Xenon is coming to be with the rest of the commoners. IF3, XEF2.
Mr. Heller, so the lone pair, so because that one with 3 lanes, and I has 7,
Mm-hmm.
so I need 2 sets of lone pairs,
On IF3? I believe so. Yep.
right? Okay.
And then you have to try to figure out where they would go.
Literally don't.
Which, it's not super important. As long as you draw 2 lone pairs, I'm fine. But if you can figure out where they actually go, it's going to help you for your molecular structure. So Molly and I are having a little conversation over here. And she's talking about IF3, and she's like, there's 2 lone pairs. I'm like, yeah, there is. Do I care where you draw them? I don't. Would it help if you drew them correct? Yeah. All right? It will help you with your molecular structure if you draw it the right way. All right? It will really help with your molecular structure. You have to think about the electrons want to get as far away from each other as far as possible. So what's going to spread them out more? I've got I have an F, I have an F, I have an F, and both lone pairs are going to go on one side. All right? That will spread everything else out more. You have to think repulsion theory. What? What did you say, Aubrey?
Because it makes it the T shape.
Yeah.
Yeah. You got it. You got it.
Stop doing that.
7, 21, total of 28. So I have, that's 8, that's 16, that's 24, plus 4 is 28. So we have an expanded octet here. Expanded octet on my iodine. You love it. EPS.
Try by pi.
Try by pi. Try by pi. Or BPY. Try by pi. Try by pi. Hybridization is SP3D. 5 sites. 1, 2, 3, 4, 5. What?
Wait, how did you get the D?
I have 1, 2, 3, 4, 5 sites.
How do you do the hybridization?
So there's one S.
Up and down arrow thing.
You don't even know.
You don't even need to know that. You don't really need to know that. You just have to know that there's 1, 2, 3, 4, 5 sites. There's 1 possible S, 3 possible P's. After that, I've got to go to my D's. So, Ishan, essentially, I'm gonna write this out. I have S1, right? But we don't show a 1. Agreed? P3 and D1. 1 plus 3 plus 1 is 5. How many bonding sites are there? 5. So it just has to add up. So sp3d is 5 for the hybridization. That's it. Molecular structure, T-shape. Molecular structure is T-shape. Angle, 90. Polar or non-polar? Polar. Down here, I got XE. I have an F. Are we not ready for this one?
Yeah, we're not ready.
Oh, sorry.
Bro, I barely even
All right, I'll pause.
I really replaced the first one.
Okay, I'll pause.
I didn't
So I got to looking at it. I wrote it down. So
I just still can't believe Panya ghosted me at Walmart yesterday.
dude,
What?
I'm disappointed.
Yeah. Yesterday I was at Walmart and I ran into Peonia and she had like her earbuds in as she was shopping. And I was with my
Kids these days.
wife and my
That's what I'm
daughters.
saying, dude.
And I was like, hi. And she just was like, and just kept walking. I'm like, she hates me.
I know. I told her that she probably ruined your day.
No, she didn't.
You
You're
ran
just-
into me at Health Point.
Peonia did?
No.
Oh, I ran into you. Yeah.
Yeah.
And you said hi.
Yeah. That's
Yeah.
what I pointed
I would have said hi.
I was like, yeah, and Aldi. I was at Aldi last night. Were you there last night?
Not last night.
Oh.
Jake is like all the
It was more of a
enthusiasm.
nod because we were both in our own situation.
Well, yeah, there was a major situation with me. One of my daughters had just hit the others on accident. Yeah. It was a teaching moment.
That sounds like.
They're actually super sweet, aren't they, Allison? Like, yeah.
That sounds
That was
sweet.
like very opposite. You were like, oh yeah, they hit each other. They're actually really sweet.
They are. They
It's
are.
an accident. It's,
But like, you know, siblings fight.
One of them pants herself in pizza.
Yes, one of them did pants herself at Pizza Hut. The Pizza Hut pantsing.
Pizza Hut
I call that the full moon.
It goes like a
The full moon.
The PHP incident.
Yes, the PHP. The Pizza Hut pantsing.
Angle with bent.
Ooh, this is.
I'm so lost. I don't have any.
The angle is bent?
That's what I'm thinking. It has to be 3 on pairs. But
It has to be 3 lone pairs, right?
I think. Is that
Or a double bond.
I mean, I feel
No,
like
Double bond's not gonna work. It's gotta be 3 lone pairs. Where are my lone pairs gonna go?
On the sides of the side of the
On the same side.
2 on this side and 1 on that side.
So it's not big.
I gotta spread them out. I gotta spread it
Oh,
out.
yeah, 'cause that forces up.
because there was no other.
It's gonna put them at like an angle, right?
You're never gonna have 3 on one side, okay? That's not gonna happen.
like,
Right? 2 on one side, 1 on the other.
all out on the other side, you know?
And remember, I posted the link to that FET on Google Classroom. So if you want to work through some of these, you can. So EPS is,
Wait, does that?
oh yeah, sorry, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There we go. EPS is try by pi.
No.
Try by pi. 1, 2, 3, 4, 5.
Yeah.
Try by pi. Hybridization is sp3d. Molecular structure is linear.
How is it linear?
Well, it's a line.
That's what the chart
All right.
But like, there's 2 on this side and 1 on this side.
Here we go. You weren't here for this, but we'll do it again. All right. Here it is. That's what we got.
Wow.
Because it's a line.
It's like that. Okay.
Yeah.
Yeah.
Because like on paper, it's like 2 on 1.
I know. That's what I'm saying.
Program on a test.
I try to draw on paper what it kind of looks like, but you can't. These are not literally, this is not a 3D thing. The electrons, you have to think of this in a 3D. All right? They're actually around that middle thing. That's why it doesn't matter if you put 2 here, 1 there, 2 here, 1 here. They're even. No, all you have to do is go like this. You have to, so close one eye, blink really fast with, no, I'm kidding. All right. Molecular structure is linear. Angle is 180. Polar or non-polar? It's a line. Non-polar. Non-polar. There's no uneven distribution of charge there.
The lone
Right?
pairs are all around.
The lone pairs are in a circle.
Because Sean, they're
Right?
around and they're out, so it doesn't matter.
So it's not splitting it in half. It's just, is the charge evenly distributed throughout the molecule?
Yes.
It is.
But if you can't split it in half, it also works.
Okay.
Also works.
Also, so
You just had it
Xe
down.
has 8 valence electrons.
Correct.
I put 0. I don't know why.
Has 8. It's full.
You were thinking
That's
of
full.
reaction.
You were thinking of the most reactive non-metal,
Yes.
I think.
Reaction.
Last one.
Ooh,
C, double bonded. C,
Oh, we have to do this?
C,
No.
H,
What?
H, 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 H.
So I call
H,
this one the
H.
opposite of what I was doing before.
I see 1, 2, 3, and 4. This is actually pretty easy.
Dude, I know what I
Oh,
did.
yeah, that's
Right?
Don't worry, guys.
Actually
I'll
pretty
watch it.
easy. This is easy because what's going to be the same?
All the
C1 and C4. Agreed?
How'd you draw it so quick as mine?
'Cause he's
I
just
don't
good
know. And C2 and C3 are going to be the same. Agreed?
So draw it actually.
I feel like
So we're going to do EPS,
Okay, so H,
hybridization,
H.
MS, angle. I want to know my number of sigma bonds and my number of pi bonds.
Sigma.
For sigma number pi.
For each one?
EPS. I want to know what the EPS is for C1.
But isn't it just
C1 and C4 are the same, so just pick one. So give me the EPS, hybridization, MS, angle, how many sigma, how many pi, and then do the same thing for C2, C3.
They're all in the same structure.
But they're different.
New brain.
They are in the same structure, but they're different.
Because they use
New brain.
friends. That's so lonely.
This is actually pretty easy. This one is.
Yeah, I feel like that really helps.
I kind of do it.
So at this point, usually the confidence is rising, or people are like, I don't get this.
Amen.
I didn't get it yesterday.
Okay.
More of the
I'm getting
latter.
it now.
So
We got to this part.
if you are the person that's like, I don't get this, then you're going to start memorizing that chart. All right? Start memorizing that chart.
Yesterday was really bad. I really didn't understand.
Well, yeah,
anything
it was not good to stop where we stopped. All right?
That's fine.
But you should feel a lot better today.
Yeah.
Hopefully.
Your dad's a
And if you don't, that's okay. If you don't, that's okay.
Yeah, Eric sent a picture to our group chat with every single thing, all of them, like the seesaw, everything, like yesterday night. And I looked at that and almost started crying. That was horrible.
But I worked through that today, right?
Yeah.
I was just so confused last night, so I'm like,
Well, having a chemist for a dad helps.
yeah.
Yeah, that's.
That's cheating. That's basically
Yeah, but-
cheating.
Yeah, that's hacks.
Wait, that's cheating.
basically-
It's literally
Eric
cheating.
just said it's not genetic
Both?
though.
Yeah, but his dad didn't write the AP test like Violet Bonvillae's dad did.
Yeah.
What? Wait.
Do you know that Violet Bonvillae's dad actually writes the AP chemistry test?
I smell a conflict of
He writes the national worldwide
Dude, he
AP test.
did. Wow.
We'll have him in as a guest speaker.
Like forever.
Well, he's not anymore, but he did the last 5 years. But he's still like assistant to the chief reader.
Wouldn't that be a conflict of interest?
Assistant
or no?
chief reader.
Yes.
Yo, what is
All right. He's assistant to the chief.
Assistant chief
Yes.
Sigma thing.
EPS of carbon 1 is tetra.
Oh.
Hybridization of carbon 1, sp3. Molecular structure is also tetrahedral. Angle
195.
109.5. How many sigma bonds?
4.
How many pi bonds?
0.
Boom.
Wait, what? Oh, those are
I gotta get that.
1, 2, 3, 4 bonds connected, right?
What are pi bonds again?
Pi, I'm going to show you. Here we go, C2, C3. EPS is?
Tetra.
No.
Trigonal.
How many things are connected? There's 3 bonding sites.
But it's 4.
That's trigonal planar. There's 4 things. It's only 3 bonding sites. A double bond is only 1 bonding site.
Oh, okay.
Hybridization is sp2.
2.
sp2.
Now this I do not.
Molecular structure.
Triplanar.
Same. There's no lone pairs. Trigonal planar. Angle
120.
120. How many sigma bonds? Don't leave.
3. No.
Stop. There is 1, 2, 3 sigma bonds.
We got it.
And how many pi? 1 pi bond.
Dude, I'm smart.
You got
Those are
it.
the only things I got right.
You got it. You got it.
Wait, they say the sigma bonds are the
That is it for notes this chapter.